Okay, so this one right here, this is a weighted average. It says if point P has a weight of 3, so point P right here, like there's 3 weights on here, and Q has a weight of 1, find point K so that the weighted average of point P and Q. So it's looking for like the balance point. So if I had to just like guess where it'd be right here. Just based on that, you can narrow down your answers and say, okay, this number is going to be negative. So you can cross these out just to like narrow things down. So just based on the concept, if you can't do any math, like you could narrow it down pretty well. Okay, but we need a precise exact number because as you can see, it's going to be a decimal. And here is how you do it. You take the weight of 3 and you multiply it by this value. So we're going to do 3 times negative 2. And then this has a weight of 1, and it's at location of 3, so it's 1 times 3. So you have 3 times negative 2 plus 1 times 3. And then the total weight, which is 1, there's 3 weights plus 1, so 3 plus 1 is 4. So this is the denominator here in this equation. And then we solve this to find the weighted average. So 3 times negative 2 is negative 6 plus 3 over 4. We get negative 3/4. This is the correct answer. However, when I look at the answer choices, they're all in decimals. So sometimes that happens. And so we just do division to find the decimal. 3 divided by 4 is 0.75. So this is negative 0.75. So it's A. And crossing out answers is a really good test-taking strategy. When you're taking tests online, if you right-click the answers, I don't know if you knew this, if you right-click the answers, you can actually cross them out. Okay, the next one, it says, given triangle JKL with these vertices, classify the triangle, select all that apply. We're going to need to graph this. We'll graph it in a second. But what we're looking for is whether it's acute, obtuse, or a right triangle, and then whether it's equilateral, isosceles, or scalene. So acute triangles have all acute angles. So all the angles are less than 90 degrees. Obtuse triangles has one obtuse angle. So one angle that's greater than 90 degrees. Right triangles have one 90-degree angle. Equilateral, isosceles, and scalene has to do with the side lengths. So these all have to do with angles. This has to do with side lengths. Equilateral is all the sides are equal in length. Isosceles triangle has 2 sides equal. And then scalene, all sides are different lengths. Different lengths. So like 3 different lengths for sides. So that is what we're going to be looking for when we graph it. Okay, so use your graph paper that you used earlier. I have mine right here, but I'm going to when I get it to a blank space on the screen, I'm also going to zoom out so we can see better. And it just so happens all of these numbers here are positive numbers. So I can just draw like this. Just focusing on the first quadrant, because like I said, all these are positive numbers, so it's going to fit over here. And then I'm going to graph my points. So J is at 0, 1. K is at 7, 0, 1, 2, 3, 4, 5, 6, 7. And L is at 5, 6. And then connecting the dots to make the triangle. And there's a triangle. So first of all, I can look at the angles now and determine whether it's acute, obtuse, or right triangle. There's definitely no obtuse angles, so I can cross that answer out. There's no 90-degree angles either, so I can cross that out. And they're all acute angles, so it's an acute triangle. So I got that. Then I have to decide whether it's equilateral, isosceles, or scalene. It's hard to tell, to to be honest. It looks almost equilateral because all the sides are very similar in length. But I'm going to have to calculate to be sure what it is. By the way, it's not equilateral, so good thing we aren't going by what it looks like. So what I'm going to do is find the length of each side. So I'm going to use Pythagorean theorem to find the length of each side. So starting with the length of LK. It's in the screen. So LK, and just I sketched out the right triangle. This is 2 by 1, 2, 3, 4, 5, 6. So I'll do 2 squared plus 6 squared equals c squared. C equals square root of 40. So this here is length of square root of 40. I can just leave it in that format because I'll be able to compare the square roots, so I don't have to worry about that too much. Okay, and then I need to find the length of JK here. JK. And like kind of just sketching out a right triangle, it would be 1 unit by 1, 2, 3, 4, 5, 6, 7. So for Pythagorean theorem, I'm going to do 1 squared plus 7 squared equals c squared. And I got square root of 50. So good thing I didn't assume it was equilateral because already I have two sides that are different lengths. So I can cross off equilateral because it's not equilateral. It's either isosceles or scalene at this point. Okay, and then I need to find the length of JL. And just making a right triangle so I can use Pythagorean theorem. 5 units by 5 units. So it's 5 squared plus 5 squared equals c squared. Square root, c equals square root of 50. So this here is square root of 50. So now I can compare the side lengths. It looks like these two are matching, so therefore these two side lengths are the same length. And we have an isosceles triangle, and that would mean it's not scalene since you do have two sides that are matching lengths. That's how you do that one. Okay, next. Ready for the next one? Thanks. Okay. The next one here, this is a level 2, so it gets a little bit easier. I'm going to zoom in as well. Zoomed out with the graph. It says endpoints C, D are given below. Find the coordinates of midpoint M. So you have C at -2, 7, D at 4, 11, and it wants to know the midpoint. So for midpoint, we're looking for the middle of the x values, middle of the y values. Some of you might jump out at you, but you can always take the average of those two numbers, -2 plus 4 divided by 2. 2 divided by 2 equals 1. This is 1. The middle of 7 and 11 is 9. That jumps out at me. But if it didn't, just add the two values, divide by 2. You get 18 divided by 2, which is 9. And so it's this. Okay, I'm going to flip to the next page when you're ready. Okay. So then here we have, it says find x on AB such that the ratio of AX to XB is a 1 to 3 ratio. So if you have a segment and you need it broken up into a 1 to 3 ratio, you would break it up into 4 parts. So like 4 parts total, and you'd have like 1 to 3 ratio like that. There's different ways I've taught this, but I recently was taught a different way that I think will work better for everybody. So here is the new way. So we have 1-to-3 ratio. So I'm making this big, 1-to-3. And we're going to use the same equation we used for weighted average on the last page. So for weighted average, we use this equation. We're going to use that same thing. But the difference is with these ratios, you like just flip-flop the numbers here. Okay, stay with me. And then it's going to be 1 times -4. Oh, gosh. Why am I... Sorry. Redo. The 3 goes with the -4. 3 times -4. Why am I like choking? Here. Okay. 3 times -4. 1 times 2. And so in this equation, 3 times -4 plus 1 times 2 over total parts is 4, because like 1 plus 3. And then we can solve this. So 3 times -4 is -12 plus 2 over 4. -10 over 4. Divide this and you get -2.5. So x is located at -2.5, and this would be our answer. And just like looking at the concept, if this was broken up into 4 equal parts, and like it was a 1-to-3 ratio, 1 part to 3 parts, that would make sense. So it would be right here. Should use it. Those are okay. And then the next one is a level 2 problem, so it gets a little bit easier again. It says, what is the perimeter of triangle ABD? So I'm going to identify what triangle they're talking about right here. Cool. Perimeter is the distance around a shape, so we need to find like the distance around the outside. So for these vertical and horizontal lines, I can just count units. 2, 3, 4, 5 units here. 1, 2, 3, 4, 5, 6 units here. So 5 plus 6 plus the length of this side, which I don't know that, so I'm going to have to calculate. So I'll do 5 squared plus 6 squared equals c squared. Okay, so we got 5 squared plus 6 squared equals c squared. We get 25 plus 36. Cooper, what was he? We get 61 equals c squared. Square root, and c equals 7.81. Then you can add the 3 values up. So this here is 7.81. It's that length there. So you add the 3 side lengths up and it comes out to 18.81. So based on this, this is our answer. One more question. Never done. Okay, this one is like a real life math problem. One that you'll probably actually use in your lifetime, to be honest. It says you're buying tile for your bathroom floor and baseboards for your bathroom walls. In the figure, the entire polygon represents the layout of the floor. Each unit in the coordinate plane represents 1 foot. The cost of the baseboards is $2 per foot. And the cost of tile is $2.50 per square foot. Find the total cost to buy tile and baseboards for your bathroom. Okay, well, baseboards. Does everybody know what a baseboard is? Okay, baseboards are like the trim that like is along the base of your floor. I don't know if you've ever noticed, but in your house you have like this little like trim thing that goes along the bottom of your walls. So the baseboards would be the perimeter of the room. And then the tile would be the area. We're gonna need to find both. Sorry. Okay, so I need to find the perimeter of this room here, and I'm just going to count units. There's 3 units here. 3, 1, 2, 3, 4, 5, 6, 7. 5, 7, 2, 3. And then counting all this, it's 10 units. And then from here, I'm going to add up all these values. 7 plus 3 plus 3 plus 10 plus 3 plus 2 plus 7. And then adding up these values, I'll just add up like a couple numbers at a time. So 40 feet will be needed of baseboards. Each foot of baseboards is $2, so 40 feet times $2 per foot would give us $80 for baseboards. Okay, and then it wants to know the cost of the tile as well, and that would be the area of the bathroom. So we can break this up into 2 rectangles, and then to find the area of each rectangle, just like length times width. So for this would be 5 times 7, which is 35. So this rectangle's an area of 35, and then this one, I can do 3 times 10, which would be 30. And then add up those 2 areas to find the total area of that bathroom, which would be 65 feet squared. And then each square foot of tile is $2.50. Multiply those 2 numbers and get 162.50 for the tile. And the actual, it says the total cost. So we have to add up those 2 values to get the total cost. And it comes out to $242.50. Like that. And that's all. So you have the rest of the class to get the homework done.